So today's video, we're going to be talking about how to express concentration of solutions. So the last video we did about solutions was on table G, and the solute was dissolved in 100 grams of water, and you could tell if it was very concentrated solution or very dilute solution. But we need more. We need to be more specific in how to express concentration of solutions with just more than concentrated, dilute. So there's kind of 4 different terminologies for how to figure out concentration of solutions, okay? The first one is this. The first one is molarity, and we'll talk about that a little bit later on. The second one is really interesting, and that's called parts per million, or ppm. Third one is percent by mass. And the fourth one is percent by volume. But before we go over these 4 ways to express the concentration of solutions, we have to review what a solution exactly is. A solution is physically put together. The easiest one to remember is water and salt. So you put the salt, which is called a solute, that gets dissolved into a solvent. So, solute would be like NaCl or salt into a solvent. The universal solvent is water. Stir it up. Now, if you take a sample of the top, middle, and bottom of that salt water, you'll find that it's all the same. And that means a solution must be a homogeneous mixture. All right? Physically put together, a homogeneous mixture. And salt water is one example of a solution. But there are more examples other than salt and water. Air. The air around us is a mixture of gases. Nitrogen gas, oxygen gas, some carbon dioxide, and other little gases. All right? You take a sample of top, middle, and bottom of the area around you, it's going to be the same. So air is a perfect example of a mixture of gases. Now, a mixture of solids. Everybody forgets about this one. If you take copper and zinc, melt them and blend them together, you get brass. Brass is called an alloy. That is another example of a homogeneous mixture, which is a solution of metals. Another solution is petroleum. Petroleum is a solution of liquids. It has propane, octane, methane. It's got all sorts of things in it. So there's all types of mixtures. All right, not just salt and water. And remember, a solution is a mixture that is homogeneous, which means constant throughout. And you can't filter a homogeneous mixture or a solution. You can't filter it. All right? Now, remember, you physically put together solutions and you can physically take them apart. Now, the next thing we're going to talk about is the first way to express the concentration of a solution, and that is molarity. So molarity is a way to express the concentration of a solution, and obviously molarity's got to do something with moles. So here's the formula that you have to know. So this formula, moles of solute over liters of solution. It's kind of like part over whole, because the solute would be like the salt, and that's part, and solution would be the salt and the water. So this is basically part over whole. And the biggest mistake students make is, if the question gives you grams of solute, you can't put grams on top. You have to convert it to moles, then put it on top. And if the problem gives you milliliters of solution, you can't put milliliters down there. You must convert it to liters. So we'll do one right now. Okay, so here's the problem. Find the molarity of 20 grams of NaOH in 250 mils of solution. Formula: big M, which is molarity. Big M equals moles over liters. Moles of solute over liters. Well, I don't have either one of those. So it's going to be big M equals, remember, I have to convert grams to moles. And the way you convert grams to moles is whatever they give you goes on top over the molar mass. So NaOH weighs 40 grams. So this would be 20 divided by 40, and that equals 0.5. So that's 0.5 moles on top. So 0.5 moles of sodium hydroxide on top. I can't use 250 mils because it has to be in liters. So if they give you mils, this is really simple. Just divide by 1,000. So if I divide that by 1,000, I move the decimal place 3 places to the left. All right, so I get 0.25 liters. So now I have 0.5 moles over 0.25 liters. And that equals 2 big M. Remember, big M stands for molarity. So this is a 2 molar solution of sodium hydroxide. That's how you do it. Okay, now let's do an easier one. Okay, so this one says find molarity of 3 moles of H3PO4. Remember, that's phosphoric acid. That is found in colas, like Coca-Cola, Pepsi-Cola, Dr. Pepper, and other drinks. Some iced teas have it in. And remember, phosphoric acid slows down the absorption of calcium. So if you drink a lot of colas and stuff like that, you are going to slow down the absorption of calcium, and that's going to hurt your bone density. But look what I have. So I'm going to find the molarity, big M, equals, I have 3 moles of phosphoric acid, so we don't have to convert because it's already in moles. 3 moles on top. And I already have liters, so I put 2 liters. And so the formula is moles of solute over liters of solution. So I have 3 over 2, and that is 1.5 big M. 1.5 molar. Okay, so the molarity of that phosphoric acid is 1.5. Let's do a few more. All right, here's a different way to do it. So in this case, it says find the grams of NaOH given 0.5 molarity in 2,000 mils of solution. So this is a little different because we have to find the grams of NaOH. So the top part is going to be the unknown. So here's how you solve this. I know big M is 0.5, so I'm going to put down 0.5 equals. Now, we got to have, our unknown is going to be on top, but it's got to be in moles first. So we're going to put X moles. And then we can't put 2,000 on the bottom. It's got to be in liters. You divide by 1,000, or you just move the decimal place 3 places to the left. 1, 2, 3. So I have 2 liters. So there's the setup. Now watch. All I have to do is 0.5 times 2. That's 1 mole. So that's 1 mole equals 1 mole of NaOH. But that is not my answer, because I want my answer in grams of NaOH. So once I find how many moles of NaOH, I convert it to grams. So remember, when you convert 1 mole, you have to find the molar mass of NaOH. The molar mass is 40, so it would be 40 times 1. And 40 times 1 is 40 grams. So I'd have 40 grams of sodium hydroxide in 2 liters of solution. That will give me a half a molarity, 0.5 molar. Okay? That's a kind of a difficult one to do, because you have to find moles first and then convert to grams. So this is the type of question that my students hate, because the unknown is in the denominator. So look what I have. I have 2.5 big M, which is the molarity is 2.5. I've got 80 grams of sodium hydroxide, and I want to find liters of solution. So the setup would be 2.5 equals, and I want to find liters, so it's going to be X liters. Remember, I can't put grams on top. I have to convert it to moles. And since we already know the molar mass of NaOH is 40, it would be 80 divided by 40. That equals 2. So on top, it would be 2 moles. Now, all I have to do is get X out of the denominator, and the way to do that is multiply both sides by X, and then divide this. So this comes down to here, X goes over to here, and it will be 2.5 moles, 2 moles over 2.5 big M. So 2 divided by 2.5. And that gives us 0.8. But 0.8 what? Well, it was X liters, so it will be 0.8 liters. 0.8 LIT. That is your answer. Don't forget, you can't ever, ever, ever have grams on top. It has to be converted to moles. All right, we're going to do one more problem. So in this one, I give you grams of phosphoric acid. I give you 100 mils of solution, and we have to find molarity. All right, so we're going to set it up. So we're going to find big M. So this is big M equals. Now, remember, you can't put grams on top. You got to convert it to moles. So we have to find the molar mass of phosphoric acid. That would be 3 plus phosphorus is 31 plus 4 oxygens is 64, and that equals 98 grams. All right, so the molar mass of phosphoric acid is 98 grams. I gave you 49. Well, this is going to be an easy one. 49 divided by 98, that equals 0.5. So that's what goes on top, 0.5 moles. Now, I can't put 100 mils on the bottom. I have to convert it to liters. Remember the way to do that, either divide by 1,000 or just move the decimal place 3 places to the left. So if I move it 3 places to the left, it'll be 1, 2, 3. So I will have 0.1 liters on the bottom. 0.1 liters on the bottom. So now 0.5 moles divided by 0.1, that will give us 5 big M. So one more time, molarity, big M, is moles of solute over liters of solution. Okay, that's the first type of expression of concentration. Now, how to make a supermolar concentration, in other words, very concentrated concentration. Well, you got moles of solute, which is like salt on top. You got liters of solution, which is everything on the bottom. To make the highest concentration, watch how this works. This is really pretty cool. If I double the amount of solute on top, that will double the molarity because that's a direct relationship. If I cut in half the moles of solute, then the molarity is cut in half, all right? So that's a direct relationship between moles of solute and molarity. But what if I double the amount of water? If I double the amount of water in the solution, that makes it more dilute. That will cut in half that. So this to this is an indirect relationship. Everybody got that? If I cut in half the amount of water here, that would double the molarity. So this, from liters of solution to molarity, that's an indirect relationship. From moles of solute to molarity, that is a direct relationship. So if I quadruple the amount of solute in the solution, then the molarity would quadruple. If I would quadruple the amount of water in the solution, then the molarity would be cut to 1/4. So you have to know the relationship. All right, one more time. Direct relationship between the moles of solute and molarity, indirect relationship between the liters of solution and molarity. Okay, so that's it for molarity. The next video will be on parts per million. I hope you understood this.